All right, so in today's lesson, we're going to talk about something called the definite integral. And this is section 7.3 and 7.4 that I combined the two sections into one. Okay, so we have discussed the integral at this point, or the antiderivative, and we've talked about like how to find it. Now, what we're going to look at today is something called definite integral, which we can use, for instance, like to calculate areas. Okay, so we know like how to find the area of like rectangles and squares and triangles. You know, those common geometric shapes. Like that's something that we already know how to do. But if we have like a function that has like a weird shape, okay, one way of figuring out what the area is going to be is we can actually use antiderivatives to calculate the area, okay? So I will show you how to do that today in this lesson. To begin with though, we have here an example of a function. So this is the function f of x equals the square root of 4 minus x squared. And what I want you to do is to just calculate the area. Now, right here, because I gave you the graph already, and you see that the graph, what it looks like is really just like a quarter of a circle, okay? So we can actually calculate this area by using, you know, a formula that we already know of. Remember, like the area of a circle is pi r squared. Okay, that's how you find the area of a circle. So r is the radius. So in this case here, we have, like I said, a quarter of a circle. Like if we, you know, you can imagine this being a whole circle. This is just a quarter of it. So the radius of this circle here is 2. Okay, that distance is 2. So if I ask you to figure out what the area of this would be, so we know the area of a circle is pi r squared, but this is just a quarter of a circle. Okay, so to find the area, it would just be a quarter times pi r squared, and then the value of r is 2 in this case. That's the radius, like we said. So that would basically just give me, let's see here, 1/4 times pi times 4, which is really just going to simplify because the 4s are going to cancel right here. It's just going to simplify down to pi. Okay, so my area for this quarter of a circle here is going to be pi. And then usually when we calculate an area, it's in square units. So that would be my answer in this case. Okay, we were able to calculate the area here by simply just looking at the graph and realizing that what the graph of this looks like is just, you know, part of a circle. Since we know how to find the area of a circle, this is a formula for area of a circle, pi r squared. This would just be 1/4 of that. So I did that right here, and that gave me the area. Okay, so this is how you can find the area, like I said, using geometry. So geometry would be like a geometrical shape that you're already familiar with, like rectangles or squares or triangles or circles. Okay, now if you graph your function, but it is not a geometric shape that we're familiar with already, then to find the area, what we're going to do is we're going to use integrals, like I said. Okay, so the types of integrals that we're going to use is something called the definite integral, which is what the topic of this section is about. So here is what a definite integral looks like. We have discussed already like how to write down an integral or how to write down an antiderivative. So you notice, remember, this is like the integral sign, and then we would have our function f of x and then dx. Okay, this is kind of like the notation that we've seen up to this point when it comes to like finding the integral or finding the antiderivative. What's going to happen now, the notation is going to change a little bit. So you're still going to have the integral sign, but then on top and bottom of it, you'll see here in the notes, you have a and b. So a and b are going to be numbers, okay? So there are going to be numbers attached to your integral, and then you're going to have your function. So to do this, we are going to have to find the antiderivative, okay? And then you know how before we talked about, like, you would find the antiderivative and then you would put plus c at the end? But instead of putting plus c at the end now, we're going to have to plug in the numbers that were attached to your integral sign, okay? It's fairly easy to do. It's not really complicated, as long as you remember how to do the antiderivative. Okay, so let's just go ahead and do this example right here, and I'll show you. Okay, so right here, I want to find the integral from 4 to 6, and then my function is 5x dx. So what I'm going to do first is I'm going to find the antiderivative. So find antiderivative. That's the first thing you do. So I have 5x, okay, the 5 is multiplied to the x, so what's going to happen is that the 5 will stay there, and then x is the same thing as x to the power of 1. So when you do the antiderivative, remember what you do is you add 1 to the power, so 1 plus 1 is going to be 2, and then you're going to put 1 over that number in front of it, okay? So x is going to become 1/2 x squared, but then the 1/2 is also multiplied to the 5. Which we had in front. Okay, so that's the same thing as just 5/2 x squared. Okay, that's my antiderivative. What I'm going to do now is that instead of putting plus c, like how we were doing before, this time around, I'm going to draw a line right there after the antiderivative. I do not put plus c. Instead, I'm going to put these numbers that I had. Okay, I had 6 and 4. 6 is on top, 4 is on the bottom. What I'm going to do now is I'm going to evaluate. Evaluate means just plug in those numbers, okay? Now, when you plug in the numbers, in the notes here, you see it says f of b minus f of a. So b is like when you plug in the top number, and a is when you plug in the bottom number, okay? So you always plug in the top number first. Plug in top number first. Then you're going to subtract, plug in bottom number. Okay, so right here, I'm going to plug in 6 first. So that's going to be 5/2 6 squared. And then I'm going to subtract. You always subtract. You see in the formula right here, we're subtracting. And then I'm going to plug in the bottom number. So 5/2 times 4 squared. So this is something that you just do on your calculator. Let's see. 5/2 times 6 squared is 30. Oh, I'm sorry, I made a mistake right there. That should be 5/2. Sorry about that. 5/2 times 6 squared. That's 90. Okay, not 30. And then I'm going to do 5/2 times 4 squared. That's 40. So 90 minus 40 is going to give me 50. And that's my answer. Okay, so what you do is you take the antiderivative, like we were doing before, but now we don't put plus c at the end. Instead, we plug in the numbers that were attached. Okay, so here we had 6 and 4. We plug those numbers in. You always plug in the top number first, and then you subtract, and then you plug in the bottom number. And then whatever you get from that, that's your answer. Okay, so this answer right here could represent like the area in this case. Okay, so if we were to look at the area from 4 to 6, the area would be 50. Okay, but this is kind of like the method that we would use to calculate the area. All right, here's another example. So I have the integral from -2 to +3, and then it's 6k squared minus 2k plus 1 dk. All right, so remember, and this is something that I did, I believe I told you guys this before, but you see how at the end of this one we have dk, and then before we had dx. The dk and the dx, and it could be d whatever letter, it's simply there to let you know what variable we're using. Okay, so in this case here, we're using k as our variable. All right, so to do this, we're going to first do the antiderivative. So we're going to start with the antiderivative of 6k squared. So the 6 is going to stay because it's multiplied to it. And then k squared, I'm going to add 1 to 2. So 2 plus 1 is 3. And then I'm going to put 1 over 3 in front of it. And this is multiplied to the 6. Minus, then I have 2k. The 2 will stay there. And then I have to find the antiderivative of k, which is k power 1. I'm going to add 1 to 1. That's going to be 2. And then it's going to be 1 over 2 in front of that. And then plus 1 is going to be 1k. Okay. If you remember the rule, if you have a number, it's just going to be the number times x. So here it will be 1 times k because the letter that we're using is k. Okay. Remember your antiderivative rules that we had discussed. So that those are the rules that I'm using. Okay, if it was a number, it's just a number times x. If you have x to the power of something, you add 1 to the power, and then you have 1 over that number. Okay, let me go ahead and simplify this first. So 6 times 1/3, that will be the same thing as 2k cubed minus here, the 2 times 1/2, the 2's are going to cancel, so that's just going to be minus k squared plus k. That's my antiderivative. Now, usually I would put plus c, but because there were numbers right there attached to it, I have to plug in those numbers. Okay, so I'm going to draw a line, and then 3 on top, 2 on the bottom. I'm going to start by plugging in the top number first. You always plug in the top number. So 3 goes in first. You're going to plug 3 in for k. And then we're going to subtract, and then we're going to put the bottom number in for k. Okay, now I like to do them separately, so I'm going to figure this one out first, and then that one, and then I'm going to subtract them. Okay, it just, you're less prone to making a typo on your calculator that way. Okay, so 2 times 3 power 3 minus 3, you can use parentheses if you want, 3 squared plus 3, that gives me 48. And then minus, now I'm going to do the same thing with -2. So 2 times -2 power 3 minus a -2 plus a -2. That gives me -16. So 48 minus -16 will be the same thing as 48 plus 16, which will give me 64. So my answer is 64. My answer now, whenever it's a definite integral, again, definite means when you have these numbers in front of them, your answer is going to be a number. Okay? So right here you saw it's 54. The previous example that we had done, my answer was 50. So it's just a number. All right, let's keep going. So here I have the integral of e to the x, and then it's from 0 to 4. Okay, so first I'm going to find the antiderivative of e to the x. If you remember, the rule for e to the x is simply just e to the x. And then now instead of putting a plus c, I'm going to draw the line, and then the 4 and the 0. So I'm going to start by first plugging in 4. So e to the power 4, and then I'm going to subtract, and then I'm going to plug in 0. All right, if I plug in e to the power 4, so I'm going to do second ln, and then to the power 4, that's going to give me a decimal number. okay? Now, you can write that number down, but chances are on the homework, it's going to ask you for the exact value, okay? So the exact value in this case would just be leaving it as e to the power of 4, okay? And then if I do e to the power of 0, so to get e, you have to push second and then ln, okay, and then 0. That one is equal to 1. So I'm going to get e to the 4 minus 1. Okay, so I'm going to leave this. I'm going to box this like that. That's going to be my answer in this case, and this is the exact answer. Okay, that's the exact answer. If you needed to figure out like what the approximation answer is, like if it says like round your answer to like 2 decimal places, in which case it wants it in decimal form, then you would actually do e to the power 4 minus 1. Whoops. E to the power 4 minus 1, and then that would have been your answer. And then you just round it to however many decimal places it asks. Okay. Here's the next one. So again, here I have the integral from 2 to 7. So you have numbers there attached to your integral. And then I have 4 over x. Okay. So when it's 4 over x, I can write it, because the x is in the denominator, I can write that as 4x power negative 1. Okay, I'm trying to find the antiderivative of 4x power negative 1. And if you remember, x power negative 1 is a special case, or it's not a special case, but there is a rule for that one, for x power negative 1. And the rule is if you have the antiderivative of x power negative 1, it's ln of x. Okay, that's for x power negative 1. So if you have 4x power negative 1, the antiderivative of that would be 4 ln absolute value of x. Now I'm not going to put plus c. Instead, I'm going to plug in the numbers 7 and 2. Okay, you draw the line, and then you put those numbers that were here. I'm going to start by first plugging in 7, and then I'm going to subtract, and then I'm going to plug in 2. Okay? Now, doing this on your calculator, 4 ln of 7. Now, I know that when I wrote it down, I put absolute value, but the absolute value of 7 is just going to be 7. So it doesn't matter if right here I just put 7. Okay? That's a decimal number. And then if I do 4 ln of 2, that's also just going to be a decimal number. Okay, so my answer here, it's not going to be a nice number. So if it's asking you for what the exact value is, the exact value would just be this. That would be the exact answer. But if it's asking you to like round your answer to, let's say, like, 2 or 3 decimal places, then you would actually subtract them. So in this case, when you subtract the 2, you get, let's say, 5.01. If it was just 2 decimal places, it would round to 5.01. Okay, so it just depends on, how do they want it? Do they want it the exact answer? If it says type in an exact answer, or does it say round your answer to 2 decimal places or 3 decimal places or whatever it is? All right, so those weren't too bad. Okay, you just find the antiderivative and then you plug in the numbers. Notice on these ones, you do not put plus c at the end. On the last page, I have 2 more examples, and we're still going to be doing the same thing. You notice these are definite integrals because there are numbers there. However, though, on these ones, we are going to have to do substitution. Okay, and how do we know on these ones that we have to do substitution? So remember in the previous class, in the previous lesson, we talked about substitution, and we do substitution whenever like we have something like an inside function. okay, what we call an inside function. So right here, I have the square root of 25 minus x squared. The 25 minus x squared is like my inside. And then when I do the last one, you'll see the last one, it's x over x squared plus 1. So the x squared plus 1, which is the denominator, that's what I would consider as my inside. Okay, these are things that we discussed in the last lesson. Okay, so let's do this using substitution. So remember, if you remember from the last lesson, there's like 5 steps to doing substitution. I'm gonna do them here, just how I showed you guys last time. So first you have to pick your u, and your u is always what you have inside. Okay, so inside of my radical in this case, I have 25 minus x squared, that's u. Then step 2, I'm gonna have to find the derivative of u. So the derivative of u is gonna be du over dx. The derivative of 25 minus x squared is gonna be negative 2x. And then what I'm gonna do after that is I'm gonna switch these. I'm gonna get the dx by itself, and I'm gonna put the negative 2x down here in the denominator. Okay, once I've done that, I'm gonna come over here as step 3. I'm gonna write down my integral, so I have x. And then instead of 25 minus x squared, that's gonna get replaced with u. And then because it's inside of the square root, remember the square root is the same thing as power 1/2. So I'm gonna put power 1/2 instead of the square root so that I can take the integral afterwards. And then dx gets replaced by du over negative 2x. What's gonna happen at this point is that this x and this x is gonna cancel out. I have a negative 2 down here in the denominator. When I put it outside or in front, I'm gonna write that as negative 1/2, and it's 1/2 because the 2 is in the denominator. And then I have the integral of u 1/2 du. All right, so now I need to take the antiderivative of u 1/2. I believe that's step 4 now. So the antiderivative of, so the negative 1/2 will stay there. And then the antiderivative of u 1/2 is going to be, you have to add 1 to 1/2. That's going to be 3/2. And then you have to do like 1 over 3/2 in front. But I'm going to write it over here. So because you have to do 1 over 3/2, you're dividing by fraction 3/2. So instead of dividing by fraction, I'm going to multiply by the reciprocal. So I'm going to flip 3/2. That's going to give me 2/3. And that's what I'm going to put right here. Okay, because 1 over 3/2 is the same thing as 2/3. All right. What we had to do after that in step 5 is, if you remember, after we do the antiderivative, now we have to put it back in terms of x. Okay, so right here, simplifying this, these 2's are going to cancel. That's just going to give me negative 1/3. And then instead of u, I'm going to put in its place 25 minus x squared, and then power 3/2. Okay, because u was 25 minus x squared. Now, in the last lesson, what we would do at this point is we would put plus c, and then we would be done. Here, though, we're not done because this was a definite integral, so we have the numbers 5 and 0 that were given to us. So instead of putting plus c, I'm going to draw a line, and I'm going to put the 5 and the 0. First, I'm going to plug in 5. You always plug in the top number first. So negative 1/3, 25 minus 5 squared, power 3/2. And then I'm going to subtract, and then I'm going to plug in 0. Negative 1/3, 25 minus 0 squared, power 3/2. Okay, you plug in the number for x. We're going to do this on the calculator here. So let's go ahead and do, well, all right. So here this is 5 squared. So 5 squared is 25, right? 25 minus 25, that would be 0. And then 0 to the power of 3/2, all that would just become 0. Okay, so that first one, that would just be 0. and then minus, now let's figure this thing out. Okay, so 25 minus 0 squared. So that's 25 minus 0, which would just be 25. I can just show you. And then we're going to raise that to the power of 3 over 2. Because notice here the power is 3 over 2. That's going to give me 125. And then I'm going to multiply by negative 1/3. In fraction form, that's negative 125 over 3. So I have 0 minus negative 125 over 3, which would just turn into 0 plus 125 over 3, which will give me 125 over 3 as my answer. Okay, so all we're doing again here is, so we still need to do the antiderivative, just like how we had been doing previously. But at the end, instead of putting plus c, we have to plug in the numbers that were attached to my integral. Okay, let's do the last one. Okay, so the last one, I have x over x squared plus 1, and then it's the integral from 0 to 2. So I have 0 and 2 that I need to plug in. This one here, again, I'm going to do this one using u substitution. And my substitution, or my u, is going to be what's in the denominator. So first I need to pick my u. And u is going to be x squared plus 1, what's in the denominator. Then I'm going to find the derivative of that. The derivative of x squared plus 1 is 2x. And then what we discussed last time, so we're going to get dx by itself. So you have du over 2x equals dx. I'm going to come back to my integral over here. I'm going to put x over, instead of x squared plus 1, I'm going to put u in its place. And then dx will get replaced by du over 2x. This x's are going to go away. The 2 that I have here in the denominator, I'm going to put it out front. And because it's in the denominator, it's going to be written as a 1/2 integral. So what I'm left right here is like 1 over u. The u is in the denominator. When I move it to the numerator, it's going to be u power negative 1 du. Remember, when we do u substitution, it's like we want to end up with an integral that only has u in it. Now in step 4, I'm going to do the antiderivative. The antiderivative of u negative 1 is the same thing as the antiderivative of x to the negative 1, which is the ln. Okay, so I'm going to say 1/2 ln u. Step 5 now, I'm going to replace the u. So in place of u, I'm going to put in x squared plus 1. Okay, and then I'm not going to put plus c. Instead, I have to plug in the numbers 2 and 0 in this case. All right. Now, I should mention this again here, guys. When we did this in the last lesson, I told you that my method right now that I'm using, and also the method that I used in the last lesson, was slightly different than the method that's used in the textbook and on the homework. Same thing here. Okay, so right now what I'm doing today, I'm using the same method that I showed you in the last lesson, okay, but it's still different from how the book does it. Okay, I just wanted to make sure I clarified that for you guys. Okay, so finally what I have left to do is I have to plug in the 2 and the 0. I'm going to start with 2 first. And then I'm going to subtract, and then I'm going to plug in 0. Okay. And before I go any further, like I just mentioned, so I do this differently from the way the textbook does it. Now, if you are reading the textbook and you go by the way the textbook does it, that's perfectly fine too. You will get the exact same answer in the end. Okay. I just feel like going this way is easier, but both ways work. And you, like I said, you get the same answer at the end, okay? All right, we're gonna figure this out now here. So that's gonna be 1/2 ln 2 squared is 4 plus 1, that would be 5, minus 1/2 ln 0 squared is 0 plus 1 is 0. Okay. So 1/2 ln of 5, that's going to be a decimal. And then 1/2 ln of 1, that's actually 0. Okay, so if we want to write down the exact value, it's going to be 1/2 ln of 5 minus 0, which is just going to be 1/2 ln of 5. That would be the exact answer for my integral. And if it said to round it to, 2 decimal places or 3 decimal places, then it would be the decimal value. So if it said 2 decimal places in this case, it would round to 0.80. Okay, so it just depends on how it tells you to write down your answer, whether it wants the exact value or if it wants it rounded to a certain number of decimal places. All right, so, and that's all there is to this lesson for today, which we talked about definite integral.